something happened where human eyes could not reach, behind the blinding circle of the sun, in a region of space hidden from every telescope on Earth. On October 29, 2025, at 7:47 a.m. Eastern Time, an object known as 3I Atlas reached perihelion, its closest point to our star, 203 million kilometers from the solar surface. It was an interstellar comet, a traveler from beyond our system, completing a journey that began nearly 10 billion years ago. For the first time since the early universe, it felt the warmth of a new sun. Then it went dark. For 8 days, 3I Atlas remained hidden behind the sun, completely invisible. Every ground-based telescope went blind. Even the best space observatories, orbiting far from Earth, lost sight of it. During that unseen period, the object passed through the most intense radiation and gravity it would ever experience. When it emerged, something had changed. In the final hours before disappearing, astronomers noticed the first anomaly, a rapid surge in brightness. Instead of brightening gradually, as comets normally do when sunlight heats their icy surfaces, Atlas began glowing at an exponential rate. Within hours, it became several times more luminous than models predicted. Then came the impossible part. Its color shifted toward deep blue. A comet's surface should be hundreds of degrees colder than the sun. It should reflect yellow-white sunlight, not emit light of its own. But Atlas appeared bluer, meaning hotter, than the sun's photosphere. Something about its light did not make physical sense. When the object reappeared on October 30th, the Punch satellite caught the first post-eclipse images. NASA's tracking system reported a normal orbit. No deviation, no course correction, no gravitational slingshot that could send it toward Earth. But data gaps began to appear in the public record. High-resolution photos from the Mars Reconnaissance Orbiter, taken weeks earlier during a close pass near Mars, were never released. China's Purple Mountain Observatory, which had been publishing daily tracking reports, suddenly went silent, citing scheduling conflicts. The missing information raised the first real question. What happened while it was hidden behind the sun? To understand the mystery, it helps to understand what this object is, or may be. Measurements suggest that 3I Atlas formed around 10 billion years ago, long before our sun even existed. Our solar system is roughly 4.5 billion years old. That means Atlas originated in a much older environment, during a time when the galaxy itself was still forming through collisions of giant gas clouds and primitive stars. It is not just from another star system, it is from another era of the universe. And that raises a problem. Comets are fragile. They are made of ice and dust, weakly held together. Over billions of years, radiation should erode them and gravity should tear them apart. Yet this object survived. It remained structurally intact across cosmic time through supernova radiation, stellar winds, and gravitational tides. Somehow, it endured. The first clue that 3I Atlas was unusual came from its trajectory. Instead of arriving at a random inclination, it entered our system almost perfectly aligned with the ecliptic plane, the thin disk where all major planets orbit. The chance of that alignment happening naturally is estimated at 1 in 500. Its approach also placed it near Mars, Venus, and Jupiter within a matter of weeks, and timed its perihelion so that it passed directly behind the Sun, invisible from Earth. Stack those probabilities together, and the odds of random coincidence drop below 1 in 100,000. Then came the sunward jet. From July through August 2025, telescopes including Hubble and several observatories in Chile and Hawaii recorded something no one had seen before. The comet was venting material directly toward the Sun instead of away from it. By every law of cometary physics, solar radiation should push gas and dust outward, forming a tail that points away from the Sun. But Atlas did the opposite. It released a steady, focused stream of gas toward the heat source, maintaining that reversal for weeks. Then, abruptly, the jet vanished in early October, the same period when the comet passed behind Mars and moved towards solar conjunction. When it returned to view later that month, the jet had flipped back to normal. The direction had corrected itself. No natural model explains how a comet reverses the thrust of its gas emissions and then restores it. Whatever mechanism caused the anti-tail shut off exactly when the object entered the region hidden from Earth. The chemical signature spectral data deepened the puzzle. When astronomers analyzed the gases venting from Atlas, they found high concentrations of nickel vapor, roughly 4 grams per second, but almost no iron. In every natural cosmic object, iron vastly outweighs nickel. They are produced together inside stars. The ratio observed in Atlas matched the kind of nickel-rich alloys used in high-temperature engineering on Earth, not the chemistry of comets. Statistically, the chance of finding such a ratio in a natural body is under 1%. At the same time, the water content was shockingly low, only 4% by mass compared to the usual 70 to 80% in ordinary comets. It was venting some water vapor, enough to make it visible. But the nucleus itself was dry and dense, more rock than ice. That composition placed it somewhere between a metallic asteroid and an engineered object. Another anomaly appeared in its polarization pattern, the way light waves align after reflecting from its surface. Atlas produced polarization levels never recorded in any comet. Each of these findings might be dismissed alone, but, together, they form a pattern that simple physics struggles to explain. A chain of improbabilities. One more coincidence fed the growing speculation. The comet's inbound path lined up within 9 degrees of the origin direction of the famous WOW radio signal detected in 1977. The 72-second narrowband transmission once thought to be artificial. The probability of that alignment by chance, less than 1%. Multiply all of these low probabilities, the orbital alignment, the timing, the nickel ratio, the water deficiency, the polarization, the WOW signal direction, and the combined odds fall below 1 in 10 quadrillion. To visualize that, imagine winning the Powerball lottery 34 million times in a row. The math doesn't prove intent, but it pushes the limits of coincidence. What happened at perihelion? As Atlas moved closer to the Sun, its behavior grew more extreme. Instead of a steady increase in brightness, the light curve followed a steep exponential relation. Intensity increasing with the inverse of its distance raised to the 7.5 power. That is far beyond any natural model for volatile sublimation. It means the comet's brightness was rising almost explosively as it approached the Sun. Space-based solar observatories, Stereo A, SOHO, and GOES-19, recorded an expanding halo around the object, nearly 300,000 kilometers wide, about the distance from Earth to the Moon. The halo was structured, showing faint layers and symmetry rather than random gas flow. Then the color data arrived. Spectrographs from SOHO and GOES confirmed that the light was indeed bluer than the Sun, implying emission from a source hotter than 5,800 Kelvin. No known natural process on a comet can produce that. Researchers considered fluorescent gases, cyanide and carbon compounds excited by ultraviolet sunlight. But the intensity was too strong, the wavelength too short. They examined whether reflection from bright ice could mimic the effect, but a 10-billion-year-old surface should be darkened by radiation, not mirror bright. The instruments were functioning normally. Multiple teams confirmed the readings. That left only 2 options. The data were wrong, or our understanding of cometary energy sources was incomplete. If the data were right, the object possessed an internal heat source. What kind could survive 10 billion years? Some scientists proposed radioactive decay within a dense metallic core. Others quietly wondered if it could be a machine, a probe designed to harvest energy from stars during close passes, recharging itself for another cycle through interstellar space. It was a speculative idea, but even skeptics admitted that the observations did not rule it out. If such a craft existed, it would need to operate automatically for geological timescales, using periodic encounters with stars to replenish power. The same way a solar panel charges from sunlight, but on a cosmic scale. A perihelion pass like this could have been a refueling maneuver, yet the trajectory showed no deviation, no thrust, no maneuver, no observable correction. If it were artificial, it was either dormant or uninterested in us. The missing data. The timeline around the hidden period remains the most suspicious. Before perihelion, the anti-tail pointing toward the sun, unusual emissions, rising brightness. After perihelion, normal tail, normal trajectory. Whatever anomaly existed, it ended behind the sun. China's data stopped exactly then. NASA withheld images from the Mars orbiter taken just weeks before. For now, the scientific record shows only before and after, the critical 8 days erased by geometry and silence. As of late October, radio observatories began listening for any emissions, any repeating signal, pulse, or narrow band frequency that might hint at artificial origin. None were found. The object remained radio quiet. Meanwhile, the JUICE spacecraft, on its way to Jupiter, scheduled 2 spectroscopic observations in November. At its current distance, the probe could not take photographs, but could record the chemical signature of the gases. The data would not arrive on Earth until February 2026 because of transmission delays. Until then, the story would remain incomplete. What we do know is that 3I Atlas survived intact. Despite intense radiation and tidal stress near the Sun, it did not fragment. Even pristine comets, fresh ones from our own Oort cloud, often disintegrate at perihelion. This one endured. Its cohesion suggested a dense, possibly monolithic structure, with internal strength far beyond that of a rubble pile comet. That fits a metallic or rocky composition, not a snowball of ice. And the nickel outgassing continued, 4 grams per second for months, roughly 40 tons in total. Nickel's boiling point is nearly 3,000 degrees, far higher than any temperature Atlas experienced. To vaporize that much metal would require a heat source not yet explained by known physics. Again, natural chemistry fails to account for it. Scale of the object. To grasp its magnitude, consider that 3I Atlas measures roughly 5 kilometers across and weighs around 30 billion kilograms. If it were artificial, its creators would have mastered technologies far beyond our comprehension, constructing mountain-sized vessels, accelerating them to interstellar velocities, and keeping them operational for billions of years. By comparison, our largest rocket, SpaceX's Starship, is 120 meters tall and can carry 100 tons to orbit. The difference is beyond imagination. If the object is technological, it might not even have a living civilization behind it anymore. It could be a relic from a species long extinct, still performing a program set in motion when the universe was young. A silent witness, not a messenger. But even without speculation, its existence challenges our understanding of what nature can produce and preserve. How does a body survive 10 billion years of radiation and impact erosion without breaking apart? How does a comet maintain structure after crossing so many stellar systems? Either it is built from something far stronger than ice, or something we have yet to discover about long-term stability in interstellar materials. What comes next? From November through January 2026, observatories worldwide will track its outbound path. The International Asteroid Warning Network is coordinating a joint campaign of optical, infrared, and radio monitoring. If 3I Atlas changes velocity, even slightly, they will know. So far, its motion remains purely gravitational. No thrust, no acceleration, no signal. On December 19th, the comet will make its closest approach to Earth, about 269 million kilometers away. That is not near enough to be dangerous, but close enough for precision observation. Both the Hubble Space Telescope and the James Webb Space Telescope will point their instruments toward it. Webb's infrared sensors can detect internal heat sources or temperature gradients across the surface. If the blue emission corresponds to actual heat, Webb will find it. Hubble will capture visible light images to map the tail and rotation. Dozens of ground observatories, from Chile to Hawaii to Europe, will join in. The goal is simple: determine whether the light, chemistry, and motion of 3I Atlas can be explained by any known natural process. If not, then the question of artificial origin will move from speculation to scientific debate. For now, the evidence is incomplete, but compelling. An interstellar body 10 billion years old, low in water, rich in nickel, aligned with the planetary plane, venting toward the sun, glowing hotter than expected, and surviving the sun's furnace intact. Each fact alone is strange. Together, they redefine what a comet can be. Behind the sun, something happened. Perhaps a burst of outgassing, perhaps an internal reaction, perhaps nothing at all. But since that hidden interval, the object has behaved normally again, as if whatever process occurred there has now ended. The human reaction. Across observatories, scientists continue to measure, calculate, and debate. Most maintain the conservative position. Atlas is natural, though rare. Some call it a fragment of a destroyed planet, a piece of metallic core ejected into interstellar space billions of years ago. Such fragments would contain nickel-iron alloys, explaining the emission without invoking technology. A few researchers remain open to other possibilities, emphasizing that until we have more data, no conclusion is final. Meanwhile, the public imagination has done what it always does: fill the silence with stories. In forums and podcasts, people call it an ancient probe, a messenger from another galaxy, even a dormant machine. Reality is quieter. What we have is an object older than our sun, behaving in ways nature rarely does, challenging models we thought complete. As of now, 3I Atlas continues to recede from the sun at 210,000 kilometers per hour. Each day, it moves farther into darkness, its brief visit recorded in millions of data points. By mid-November, it will cross the orbit of Mars. By year's end, it will be near the asteroid belt. By late 2026, it will pass Jupiter's orbit and drift back into interstellar space, carrying whatever secret it holds. In the months ahead, as new data arrives from Webb, Hubble, and JUICE, scientists will piece together the full picture. Until then, the truth remains uncertain. Was the light purely chemical? Was the blue glow a trick of the sun's reflection? Did the anti-tail mark a jet of gas or an engineered exhaust? Every possibility remains open, but one fact stands unchallenged. For 8 days in October 2025, an object older than the galaxy's calm phase vanished behind the sun, and when it returned, the universe seemed a little less familiar. That is the story so far. The rest will unfold in the next phase of observation, and in the long questions that follow when data ends and imagination begins. When 3I Atlas reappeared from behind the sun, the world of astronomy held its breath. For 8 days, the interstellar object had been completely invisible, its trajectory hidden by the sun's overwhelming glare, its instruments unreachable, its data streams interrupted. Then, in the quiet hours of October 30th, a faint blue glow emerged again in the field of the Punch satellite constellation. It was the first confirmed sighting after perihelion, and for a brief moment, the entire global network of observatories pivoted their attention toward that one point of light. The first readings confirmed that 3I Atlas had survived intact. No signs of fragmentation, no secondary debris trails, no indication of catastrophic breakup. It had endured one of the most extreme gravitational and thermal encounters a comet could experience, and it came out unscathed. That simple fact, by itself, defied precedent. Astronomers expected a degraded remnant, a cloud of dust and vapor marking the end of an object too ancient and too fragile to survive a close solar pass. Instead, what they found was something stable and bright, moving exactly as predicted by Newtonian mechanics, Yet there was an undercurrent of unease. When the Punch and SOHO satellites compared post-perihelion images to pre-perihelion ones, subtle differences appeared. The tail, once erratic and bent toward the sun, now streamed perfectly outward. The object's brightness curve stabilized, but its spectral profile, its color signature, remained puzzling. The blue hue persisted, though weaker. It was not a brief flash of solar reflection. It was a sustained emission, continuous and steady, like a cold flame burning in the dark. Teams at NASA, ESA, and JAXA began cross-referencing the data. What was supposed to be a short observational campaign became a global investigation. The initial reports from NASA's heliophysics division described anomalous radiative behavior inconsistent with standard cometry models. That was the careful, scientific way of saying that no one knew what they were looking at. The raw numbers suggested a heat signature far too intense for a body composed of ice and dust. The amount of energy being released couldn't be accounted for by sunlight alone. Either the object's surface reflected light with an efficiency no known material possessed, or there was an internal process, chemical, radioactive, or mechanical, releasing energy from within. At the same time, the missing Mars Reconnaissance Orbiter images continued to draw suspicion. According to official records, the spacecraft's high-resolution camera, HiRISE, had taken several shots when Atlas passed within 30 million kilometers of Mars. Normally, such data would be public within days. This time, nothing was released. Scientists requesting access were told the files were under internal review. When pressed, NASA's Jet Propulsion Laboratory issued a brief statement citing data prioritization for ongoing Mars surface operations. It was plausible, but it didn't satisfy anyone. The gap was too specific, too conveniently timed with the onset of anomalies. China's Purple Mountain Observatory was equally silent. After months of consistent updates, they stopped publishing positional data entirely. The official explanation referenced lunar observation conflicts. Few believed that. Their telescope array was capable of multi-target tracking, and the sudden halt coincided precisely with Atlas's closest encounter with Mars. In the absence of transparency, speculation filled the void. Theories multiplied. Some suggested that the object might have changed trajectory slightly while hidden behind the sun, that perhaps it performed a maneuver too subtle to register immediately. Others argued that if such a shift had occurred, the global tracking systems would have noticed. But then came the next development, an unexpected report from the European Space Agency's Solar Orbiter mission. The Solar Orbiter's cameras had captured something faint, yet significant, during the days Atlas was behind the sun. In a single frame sequence, analysts noticed a brief pulse of light not consistent with solar flares or cosmic rays. It was directional, localized to a moving point that matched the predicted path of 3I Atlas. The pulse lasted only seconds, but it was real. Scientists labeled it Transient Emission Event 2025 to 1026, and the data was quietly shared with NASA. No public statement followed. The report described it as inconclusive, suggesting possible sensor reflection, though internal logs confirmed the instruments were functioning normally. By the first week of November, public interest had reached a fever pitch. News outlets picked up fragments of interviews, mixing facts with sensational claims. Some headlines declared that an alien probe had been found. Others accused governments of hiding proof. Meanwhile, professional astronomers continued their work, carefully separating measurable data from conjecture. They began cataloguing every known anomaly associated with Atlas into a single document, the first comprehensive timeline of the object's behavior. The list grew to 9 major irregularities, from trajectory alignment to composition and light polarization. It became clear that even if 3I Atlas was natural, it was unlike any comet previously observed. One key revelation came from the SOHO spacecraft's LASCO coronagraph. By analyzing the coma, the vast halo of gas surrounding the nucleus, Scientists determined that the gas density fluctuated in rhythmic intervals. Every 43 minutes, the emission rate spiked slightly, then fell back. That pattern repeated consistently over several days. Periodic outgassing is not unusual for rotating comets, but the precision of the cycle, regular to within seconds, was startling. Natural spin-induced venting tends to vary over time. This did not. It was as if the object's rotation or internal structure maintained a perfect rhythm, a kind of mechanical precision that bordered on artificial. Astronomers debated possible explanations: a highly symmetric nucleus, internal layering, or resonant fractures releasing gas in synchronized bursts. The pattern persisted until late November, when it gradually diminished. By then, the European Space Agency's JUICE spacecraft had begun its scheduled observations. Though far away, its ultraviolet spectrometer detected something new: traces of molecular nitrogen and metallic oxides uncommon in comets. The readings hinted at a surface dominated by metallic compounds rather than silicates or ices. Combined with the earlier detection of nickel, this pushed the narrative further toward a metallic origin. At the same time, the James Webb Space Telescope began preparing for its December observation window. Webb's infrared instruments would be capable of detecting any heat emanating from within the object, even faintly. The team responsible for the campaign issued a statement: "If there is an internal energy source, Webb will find it." But they also added a warning: if the heat distribution matches natural solar heating, it will rule out most artificial hypotheses. The world waited for that test. Meanwhile, the Hubble Space Telescope conducted follow-up imaging using multiple filters. The resulting photographs, captured in early November, revealed an object with surprising structural uniformity. Most comets display irregular shapes, fractures, or diffuse tails. Atlas appeared smoother, more compact, with a faintly reflective surface. Hubble's team described it as geometrically stable, another polite scientific phrase for oddly perfect. When they adjusted contrast levels, subtle linear features became visible across the nucleus. Parallel streaks aligned almost precisely with its rotational axis. They could be nothing more than surface fissures, but their spacing appeared evenly distributed. The image analysis teams hesitated to draw conclusions, but noted that the symmetry was not characteristic of known comet morphology. Then came the radio silence. Literally. Throughout November, the world's largest radio telescopes monitored Atlas across a wide frequency range. The Very Large Array, Parkes Observatory, Green Bank Telescope, and FAST in China all participated. The goal was to detect any non-random signal: a pulse, a repeating tone, anything distinct from natural noise. None was found. The object was quiet. But quiet itself became part of the mystery. Interstellar comets normally produce faint chaotic radio emissions as their ions interact with solar wind. Atlas produced almost none. Its radio profile was unusually clean, as if it absorbed or neutralized charged particles rather than scattering them. By mid-November, 3I Atlas had moved outward beyond the orbit of Mars. It was growing dimmer, yet the interest around it showed no sign of fading. Theories continued to branch in two directions, one conservative, one speculative. The conservative model described it as a fragment of a long-dead planet, a remnant of a metallic core torn apart billions of years ago. The speculative model viewed it as an engineered object, perhaps a probe or automated system traveling through the galaxy. Both sides agreed on one thing: it was not a typical comet. The hypothesis of a planetary fragment gained traction when Dr. Lenora Brooks from the University of Cambridge published a paper examining Atlas's metallic emissions. She proposed that its low water content and nickel-rich composition fit the profile of a planetary mantle remnant. In her model, an ancient world once orbited a massive star that went supernova, scattering its fragments into interstellar space. Atlas, she argued, could be one of those fragments. ejected at high speed and wandering for billions of years before reaching our system. The idea was elegant and consistent with most observations, but it couldn't explain the blue light emission or the sunward jet reversal. Those two anomalies remained unresolved. In the absence of answers, people turned philosophical. What did it mean for humanity to witness an object that predates the Earth? For centuries, comets had been seen as omens, symbols of change. This one seemed to fit that ancient narrative, though now the change was intellectual. It forced scientists to confront the limits of their understanding. How much of what we call impossible is simply something we haven't yet observed enough times? Every major discovery begins as an anomaly, an outlier in the data that refuses to fit the model. The next milestone would come on December 19th, when 3I Atlas would reach its closest point to Earth, 269 million kilometers. It wasn't near enough to be dangerous, but it was close enough for unprecedented observation. Nearly every major observatory scheduled time on their instruments for that day. The European Southern Observatory in Chile, the Keck Observatory in Hawaii, the Gemini North and South telescopes, and Japan's Subaru telescope, all coordinated to create a continuous 24-hour watch, ensuring no moment would go unrecorded. As the object drifted farther from the sun, its glow began to soften. The tail extended hundreds of thousands of kilometers into space, faintly illuminated by reflected light. Amateur astronomers using high-power telescopes could spot it in the pre-dawn sky near Venus, a dim, bluish smudge against the blackness. For the public, it was a beautiful sight. For scientists, it was the calm after a storm of anomalies. Yet within that calm lay the most important phase of the investigation, the quiet period where data would be collected meticulously, every emission measured, every deviation tracked. Then, in late November, a small yet intriguing signal came from the Spherex Space Observatory, which scans the sky in infrared wavelengths. It detected a faint trace of carbon dioxide and carbon monoxide emissions near Atlas, ordinary gases for a comet, but in far lower quantities than expected. This reinforced the image of a dry, depleted body, ancient and mostly metallic. But the ratio between carbon compounds and nickel ions was still wrong. The nickel remained disproportionately high, suggesting continuous venting from deep within the nucleus. The process did not appear to slow with distance from the sun. That observation alone implied that solar heating wasn't the driving factor. Something else was maintaining the release. On December 1st, the International Asteroid Warning Network issued a detailed bulletin summarizing all known data to date. Its conclusion was cautious but firm. 3I Atlas presents a unique and unprecedented opportunity to study an interstellar body with anomalous physical characteristics. While current evidence does not support any claim of artificial origin, several phenomena remain unexplained. Those words, "remain unexplained," became the heart of every discussion. Meanwhile, whispers began circulating within research circles about a leaked internal memo from a joint NASA-ESA working group. According to the leak, the withheld high-rise images from Mars' orbit allegedly showed an unusual geometric shadow across the object's surface, something rectangular, consistent across multiple frames. The authenticity of the memo was never confirmed, but the rumor was enough to ignite renewed public attention. NASA declined to comment, fueling the speculation even further. Throughout this period, the global focus shifted subtly. What had begun as a scientific observation evolved into a question of identity, not of the comet, but of humanity itself. What if it really was artificial? What would that mean for us? Would it prove that intelligence elsewhere in the universe had once existed? Or would it simply remind us how fleeting civilizations can be, leaving behind machines that wander forever through the void? For most astronomers, the goal was not to chase mystery, but to gather truth. The James Webb and Hubble campaigns were the key. Their combined data, scheduled for release in early 2026, would likely decide the issue. If the heat signatures and emission patterns matched natural physics, the story would end there. If they didn't, it would open a door that science has avoided for decades. Until then, 3I Atlas continued on its way, silent, steady, moving outward at more than 200,000 kilometers per hour. By December, it was already well beyond the orbit of Mars, its faint halo trailing behind like a blue scar in space. It no longer showed signs of volatility. The anti-tail did not return. The light curve remained stable. Everything about it now looked calm, ordinary even, as though whatever event occurred behind the sun had completed its purpose. But the universe often hides meaning in its quietest moments. The scientists watching the object knew that every observation mattered. Each photon captured by their instruments carried information from a world 10 billion years old. Each spectral line was a sentence in a language written before the Earth existed. Whether natural or not, 3I Atlas had become one of the most valuable teachers in the history of astronomy. And so, as the end of 2025 approached, the story entered its next phase, the waiting. The world would soon witness the closest approach, the crucial moment when every telescope on Earth and beyond would focus on a single target. If answers were ever going to appear, December would be the month they began. By the first week of December 2025, the excitement around 3I Atlas had spread far beyond the scientific community. It was no longer just an astronomical event, it had become a shared global phenomenon. Every major observatory, from Chile to Hawaii, from the Canary Islands to Japan, had scheduled time to capture the interstellar object during its upcoming closest approach to Earth. NASA had organized around-the-clock observation coverage through the Deep Space Network. The James Webb Space Telescope and Hubble had both finalized their targeting programs. For the first time in history, humanity would simultaneously observe an object older than the Sun itself, with nearly every advanced instrument available. 3I Atlas had now traveled past Mars's orbit and was on a trajectory that would bring it within 269 million kilometers of Earth on December 19. That distance might sound vast, but in astronomical terms, it was close enough for precise spectroscopy and imaging. It would never come nearer. For scientists, this was the last opportunity to gather data before the object began its long exit from the solar system. As the date approached, the first hints of new behavior emerged. The light curve, once stable since the post-perihelion phase, began to fluctuate slightly. At first, the variations were dismissed as observational noise, but by December 12th, instruments around the world were detecting synchronized changes. The object's brightness was pulsing. The fluctuations were small, less than a few percent, but consistent. The cycle lasted roughly 10 hours, suggesting a possible rotation period. However, the pattern wasn't uniform. The amplitude of the pulses increased and decreased with a rhythm of their own, like a beating heart. Astronomers immediately began analyzing the data. The idea of rotation made sense. Many comets tumble slowly as they move through space. But the consistency of the timing and the smooth periodic variation hinted at something else, perhaps structural symmetry or internal regulation. A comet composed of random ice and rock fragments shouldn't show such precision. The pattern was too exact. On December 14th, the first high-resolution composite images from the European Southern Observatory revealed the most detailed look yet at the interstellar visitor. What they saw deepened the mystery. The nucleus appeared unusually smooth, lacking the chaotic craters and irregular ridges typical of comets. It reflected light unevenly, suggesting areas of different composition, yet those areas formed what looked like geometric patches, long parallel zones rather than random blotches. Some researchers quietly compared them to heat-resistant plating. The idea seemed absurd, but the visual evidence left few comfortable explanations. While optical telescopes documented its surface, the James Webb Space Telescope turned its infrared sensors toward Atlas. Its detectors could measure temperature variations with incredible precision, capable of detecting changes of less than 1 degree. The results released internally to NASA teams on December 16th, showed that the object's surface temperature did not match solar heating models. Parts of the comet were warm, much warmer than they should have been at that distance from the Sun. One section of the nucleus exhibited a sustained infrared emission nearly double the expected value, while the opposite hemisphere appeared cooler. The gradient was too strong to attribute to sunlight alone. Normally, temperature differences on comets arise from rotation. One side facing the Sun warms while the other cools. But this pattern didn't rotate away as expected. The hot zone remained fixed relative to the object's axis for days. It was as if the heat source was internal, not external. Webb's principal investigators wrote cautiously, localized infrared enhancement likely due to internal compositional variation. But between the lines, everyone understood what that meant. They didn't know. Meanwhile, the Hubble Space Telescope captured visible light images with even more striking detail. On December 17th, its cameras revealed a faint halo of material surrounding the nucleus, an envelope much more structured than the diffuse glow of a typical comet's coma. The halo contained subtle arcs, evenly spaced like ripples. Computer analysis suggested they were density waves, as if something inside the nucleus was periodically ejecting small amounts of gas or dust. Combined with the brightness pulses recorded earlier, this reinforced the idea of periodic activity, something rhythmic, sustained, and deliberate. Then came the observation that would dominate headlines, the spectral shift. During Hubble's multi-filter imaging, one set of readings detected a new emission line, an unexpected wavelength corresponding to ionized nickel oxide transitioning at energies around 3,800 angstroms. That specific line had not been recorded before in any comet. Its appearance indicated a chemical reaction occurring at temperatures far higher than the comet's surroundings. Once again, the evidence pointed to heat, intense, localized, and unexplained. By December 18th, 3II Atlas had reached its optimal observing position. It was now bright enough to be captured even by large amateur telescopes. Across the world, thousands of people pointed their instruments toward the pre-dawn sky and saw, faintly, a bluish star-like object moving slowly east of Venus. The images flooding astronomy forums were raw, grainy, imperfect. But they represented something profound. For the first time, ordinary people were seeing a piece of matter forged before the Earth existed. Professional observatories, meanwhile, were preparing for the 24-hour coordinated observation marathon on December 19th. The schedule resembled a military operation. Each facility had assigned windows, ensuring continuous monitoring from every longitude. Data from radio, optical, infrared, ultraviolet, and even X-ray instruments would be cross-correlated in real time through NASA's Deep Space Network. Nothing like this had ever been attempted for a single celestial object. When the observation window began, early reports streamed in from Chile. The Very Large Telescope detected faint polarization changes in the reflected sunlight, shifts that corresponded with the same 10-hour pulse period previously observed. As hours passed, telescopes in Europe and Africa continued the sequence, confirming the pattern. Then, as night fell over the Pacific, the observatories in Hawaii took over. That's when the first truly extraordinary data appeared. At around 0340 UTC, the Keck Observatory's near-infrared spectrometer recorded a sudden spike in emission from the comet's leading hemisphere, the same region previously identified as anomalously hot by Webb. The spike lasted less than 10 minutes, rising sharply and then fading. It was accompanied by a subtle brightening, visible even in optical wavelengths. Almost simultaneously, the Green Bank Telescope in the United States reported a narrowband radio emission lasting 90 seconds at a frequency of 1.42 GHz. The hydrogen line, a frequency often used by radio astronomers when scanning for potential artificial signals because of its universal cosmic significance. The signal was faint, buried in background noise, and immediately dismissed by some as terrestrial interference. Yet the timing was impossible to ignore. The radio burst occurred precisely as the infrared emission peaked. When analysts checked other observatories, they found that 2 additional telescopes, Parkes in Australia and FAST in China, had detected the same brief spike, though weaker and slightly delayed due to geographic timing. Triangulation placed the origin directly at 3I Atlas's location. NASA's SETI division, which monitors such anomalies, issued a cautious statement hours later. "We have detected a transient radio event coincident with the optical observation window of 3I Atlas. The source and nature of the signal are under investigation." They didn't call it artificial. They didn't call it noise. They simply called it unclassified. The following days became a blur of analysis. Radio engineers combed through data to rule out interference from satellites, ground radar, or ionospheric reflection. The frequency itself was ordinary. It's the same band used by hydrogen in space, but the duration and timing made it peculiar. Natural hydrogen emissions are broad and continuous. This was narrow and fleeting. It rose sharply, plateaued, and decayed smoothly. An unnatural symmetry, yet one so subtle that skeptics could still explain it as coincidence. As the debate raged, 3I Atlas continued its journey, unbothered by the attention. Its motion remained precise, gravitationally consistent. No course change, no acceleration, no deviation. Whatever the radio burst was, it left no trace of propulsion or response. It was simply an event, a momentary whisper in the vast silence. By December 21st, preliminary data from the James Webb Telescope was released to the International Research Consortium. The temperature readings from the hot zone had stabilized, but remained 40% higher than solar heating alone could explain. That meant internal heat generation of some kind, possibly through radioactive decay or exothermic chemical reactions. Yet the uniformity of the hotspot, the fixed orientation, and the lack of surface disruption contradicted both hypotheses. Normally, a chemical outburst or radioactive region would create uneven patches, not a consistent glow. At the same time, Hubble's imaging revealed another small but telling detail: a faint jet of material emerging from the same warm region. Unlike typical cometary jets that scatter unpredictably, this one was straight, thin, and precisely collimated, like a beam rather than a plume. It extended thousands of kilometers before dispersing. Over the next few days, the jet faded, leaving only the smooth coma behind. Scientists logged it as an isolated transient event consistent with controlled outgassing, careful again not to imply intent. For the public, these events reignited fascination. The December 1920 observation window became a media spectacle. Networks broadcast live telescope feeds, showing faint dots of light accompanied by commentary filled with both awe and caution. Social media turned the comet into a cultural phenomenon. People compared it to Oumuamua, the first interstellar object discovered years earlier, though Atlas's behavior made that earlier visitor seem almost ordinary. Meanwhile, governments began to take an interest. Congressional representatives in the United States requested briefings from NASA. The European Space Agency's leadership met privately to discuss how to handle potential data release if further anomalies were confirmed. China remained silent, but continued to track the object with its deep space network. Transparency, as usual, became the first casualty of discovery. By the end of December, the raw data volume exceeded several terabytes. Teams across the world were processing it, dividing the task by wavelength range. Preliminary consensus formed around one statement: 3I Atlas was releasing more energy than could be explained by sunlight alone. Whether that meant internal radioactivity, exotic chemistry, or something else was unknown. As the comet moved farther away, brightness dropped steadily. It would never again be as visible or as closely monitored as it was during those 2 days. The telescopes began shutting down their special observation schedules, shifting back to other projects. Yet even as the light faded, the discussion did not. In late December, Avi Loeb, the Harvard astrophysicist who had long advocated for serious investigation of Interstellar Anomalies, published a short commentary paper. In it, he compared 3I Atlas to both Oumuamua and Borisov, the two previous interstellar visitors. Oumuamua, he wrote, showed unexplained acceleration. Borisov behaved like a typical comet. Atlas sits between them, a natural object with unnatural features. His conclusion was cautious but provocative. If these anomalies persist under further scrutiny, we must consider that some fraction of interstellar objects could be technological relics. The paper drew immediate criticism from conservative astronomers, who argued that extraordinary claims require more evidence. But it also galvanized a generation of younger researchers who saw in Atlas not proof of aliens, but proof of the unknown, evidence that the universe still had surprises. As 2025 came to an end, 3I Atlas had become a symbol, a quiet reminder of how little humanity truly knows about its own cosmic surroundings. It had passed close, illuminated the sky, defied expectations, and now drifted back into the dark. The final data packets from Hubble, Webb, and JUICE were scheduled to arrive in early 2026, but for now, there was only waiting. When astronomers finally turned their telescopes away from it, they did so reluctantly. Somewhere out there, moving at 200,000 kilometers per hour, was an object older than Earth, possibly carrying within it the answers to questions we have only begun to ask. It had brushed past the sun, defied known physics, emitted mysterious light, and survived intact. Whether natural or designed, it had forced humanity to look again at its own assumptions about what exists beyond the solar neighborhood. In the end, the data told a single undeniable truth. Something extraordinary had passed through our sky. For now, that was enough. But not everyone was content to let the story end there. A small group of scientists within the SETI Research Collective began quietly analyzing cross-frequency patterns from the December 19th radio burst. They noticed that the signal's rise and decay formed a nearly perfect Gaussian curve, a mathematical shape common in engineered transmissions, but rare in natural astrophysical processes. The finding was not publicized, not yet. It would take months of verification before any conclusions could be made. But among those who studied the data late into the night, one realization kept returning. If 3I Atlas truly was a probe, it had not come to communicate. It had come to observe. As January approached, the object grew dimmer each night, sliding deeper into the outer solar system. The flares of attention and speculation faded, leaving behind only numbers, graphs, and a lingering question that no one could yet answer. Something had happened behind the sun, something that changed everything about how we look at the cosmos. But the meaning of that change remained hidden, carried away with the object itself, now vanishing into the darkness between worlds. By January 2026, the light of 3I Atlas had dimmed to the threshold of detectability. Only the largest telescopes could still track its motion. An icy blue dot fading into the Black Sea beyond Mars. Yet in control rooms around the world, the object was far from forgotten. Terabytes of raw data from December's observation campaign were still under analysis. Every frame from Hubble, every photon count from Webb, every pulse from the radio arrays was being scrutinized, compared, and cross-correlated. The public had largely moved on, the news cycle replaced by other headlines. But among scientists, the silence that followed the spectacle felt heavier than the comet itself. What they were finding, slowly, carefully, and reluctantly, did not fit any of the models they had built. The first major report came from the James Webb Space Telescope team in mid-January. It summarized 3 weeks of infrared data collected before, during, and after 3I Atlas's closest approach. The conclusion was phrased cautiously, as all such documents are. Thermal emission analysis reveals non-equilibrium temperature gradients and persistent localized heating inconsistent with solar radiative forcing. In plain terms, that meant the object was producing heat from within. The Webb team had ruled out external causes. No sunlight could have sustained the hotspot pattern they had measured. No reflection geometry could have maintained it for so long. Whatever caused the thermal anomaly, it came from inside the nucleus. Normally, such a finding would ignite immediate excitement, but this time, the tone was subdued. The last few years had shown how easily speculation could outrun evidence. NASA and ESA were determined not to repeat the chaos of Oumuamua's discovery when media stories had spiraled into talk of alien ships. Instead, the language remained clinical. The report stated that internal isotopic heating, metallic oxidation, or slow chemical phase transitions were possible explanations. Yet privately, many of the analysts admitted that the data didn't support any of those options convincingly. The level of heat was too high, the constancy too perfect. In the following weeks, the JUICE spacecraft, still en route to Jupiter, began downlinking its ultraviolet spectrograph readings. These were precious. The craft's instruments had been aligned precisely to catch the faintest reflections from Atlas during its December pass. The data came in slowly, transmitted across hundreds of millions of kilometers, compressed and error-checked bit by bit. When the first sets were decoded at ESA's mission center in Darmstadt, Germany, the team found something no one expected: a new emission signature, one that didn't match any known molecular compound. The wavelength was centered at 304.6 nanometers, falling between the lines of ionized oxygen and neutral helium. It didn't correspond to any known atomic transition under ordinary conditions. The initial reaction was disbelief. Instrument error seemed likely. The team recalibrated the sensors, checked for cosmic ray interference, and compared the signal with calibration stars. The anomaly persisted. Whatever it was, it came from 3I Atlas. It was weak, intermittent, but real. The internal memo describing the finding used the term unidentified spectral feature. That phrase carried weight. It meant something entirely outside the reference database of astrophysical emissions. While European scientists were still verifying their data, the United States-based Deep Space Network completed a parallel analysis of the December radio burst. For weeks, radio engineers had combed through hours of background noise, trying to isolate any pattern. When the noise was filtered and cross-checked, one pattern did emerge. The signal's envelope had a shape almost identical to a Gaussian curve, with a rise, plateau, and fall, timed over precisely 90 seconds. Even stranger, the phase alignment of the signal between three observing stations showed that it had been coherent, meaning it maintained a consistent frequency and phase structure across the entire duration. Natural hydrogen emissions do not behave that way. Coherence implies a source with regulated frequency control, or at least a resonant structure that confines emission within narrow limits. Still, the report remained conservative. The SETI division classified the event as non-repeating transient, placing it in the same ambiguous category as the famous WOW signal of 1977. There was not enough data to call it artificial, but too much precision to dismiss it as noise. For the first time since the object's discovery, senior officials began holding private meetings with both NASA and the US Department of Defense. Whatever was behind the sun months earlier had left behind more questions than answers, and no one wanted to be unprepared if 3I Atlas, or something like it, ever returned. Meanwhile, scientists across the world began publishing independent analyses, each focusing on one part of the mystery. A group from Kyoto proposed that the nickel emissions might arise from photochemical separation caused by intense cosmic radiation during the comet's interstellar voyage. Others at the University of Cape Town modeled the object as a fragment of a planetary core stripped of lighter elements, a survivor of a catastrophic impact in another solar system. Both models could account for the metallic composition, but neither could explain the blue light, the anti-tail, or the radio event. The debate became a web of partial truths, each model solving one mystery while deepening another. As February arrived, the European Space Agency prepared a public summary. The document was 20 pages long, dense with graphs, wavelengths, and error margins, but its final paragraph was simple and profound. 3I Atlas represents a class of interstellar object whose physical and energetic characteristics challenge conventional models. Further research and missions are required to determine the underlying mechanisms. It was as close as scientists could come to saying, "We don't know." In the background, a quieter process was unfolding. The International Committee on Extraterrestrial Object Studies, a multidisciplinary advisory group formed after Oumuamua, convened for the first time in years. They reviewed the data under confidentiality agreements. Among them were astrophysicists, radio engineers, and even a handful of philosophers and sociologists. Their task wasn't just to interpret the science, it was to prepare for implications. What if, by some small chance, the object really was technological? How would humanity handle such knowledge? Would it be announced publicly, or kept under wraps until confirmation was absolute? These were questions that transcended science, and the answers were as political as they were ethical. While officials debated protocols, the comet continued outward, crossing the orbit of Jupiter in early February. Its velocity had slowed under the Sun's pull, but remained immense, around 180,000 kilometers per hour. Beyond Jupiter lay the frozen outskirts of the solar system, and beyond that, the darkness of interstellar space. Within a year, 3I Atlas would be gone forever, returning to the endless drift between the stars. Observers estimated that it would not pass near another star for millions of years. Whatever story it carried would remain locked inside its metallic heart. But data has its own kind of gravity. It pulls people toward it, even across disciplines. In March, a young data scientist from the University of Toronto, working independently, uploaded a preprint to the arXiv research server. He had analyzed the brightness fluctuations recorded by multiple observatories during December's observation window and discovered that the 10-hour periodicity wasn't perfectly stable. It contained secondary modulations, subtle frequency shifts that repeated every 71 cycles. When plotted visually, those modulations formed a nested pattern, one that resembled an encoded sequence. It wasn't binary, and there was no clear message, but it was structured. His conclusion was cautious. The periodic photometric signal exhibits characteristics that could indicate internal harmonics or artificial modulation. The paper was met with skepticism, but not dismissal. Even critics admitted that the data pattern was unusual. Meanwhile, at NASA's Goddard Space Flight Center, an internal team had been reanalyzing the withheld high-rise images from the Mars Reconnaissance Orbiter. After months of requests, the images were finally cleared for limited scientific review. Those who saw them described a small, irregular body, as expected. But one frame caught attention. A faint, elongated shadow, angular rather than curved, stretched across part of the nucleus. It could easily have been an imaging artifact, but it was distinct enough to prompt reprocessing. When the contrast was enhanced, the shadow's edges appeared straight, forming near-perfect right angles. The official explanation was that it resulted from sensor blooming, a known issue when bright regions overload a pixel array. Yet off the record, several imaging specialists admitted they had never seen a bloom pattern shaped like that. By April, the first phase of post-encounter research was complete. The final synthesis conference took place in Vienna, attended by representatives from every major space agency. The conclusions were summarized into 5 key findings. Thermal anomaly confirmed. The object exhibited internal heat inconsistent with solar radiation. Metallic composition dominated by nickel with minimal iron. Unusual, but not impossible in natural formations. Spectral emission at 304.6 netum remains unexplained. Transient radio burst at 1.42 GHz. Confirmed by multiple observatories. Origin indeterminate. No observed. Course deviation or active maneuvering detected. The official statement emphasized that no evidence of technological origin has been found, yet the data itself told a subtler story, a pattern of precision and endurance that stretched the boundaries of what natural could mean. Outside the conference, a different narrative was forming. In universities, podcasts, and documentaries, people began referring to 3I Atlas as the silent messenger. The phrase captured the paradox of the event. An object that said nothing but forced humanity to listen anyway. For every skeptic, there was a dreamer who believed it was proof of something more. For every scientist insisting on probability, there was a poet whispering about the loneliness of the stars. And then, as the months passed, new data from JUICE trickled in. Fainter now, but still discernible, the ultraviolet emissions continued intermittently well after the comet had left the inner solar system. The mysterious 304.6 nanometer line persisted long after solar heating should have ceased. That persistence baffled everyone. If the energy source was internal, it was self-sustaining. If it was chemical, it should have faded. It did neither. By May 2026, 3I Atlas was approaching Saturn's orbit. The last signals from optical telescopes dwindled to noise. From that point onward, only radio instruments could track it, and even those would soon lose contact. The object was leaving, carrying its silence with it. For the teams that had spent years on the project, its departure felt like the end of a chapter. Yet the mystery remained unsolved. Somewhere between the numbers and the noise, between the light curves and the spectra, there lingered a sense that something extraordinary had brushed against human understanding and slipped away before we could grasp it. The final summary from the International Astronomical Union, published in late May, put it best. 3I Atlas reminds us that not all phenomena yield to immediate explanation. Its passage through the solar system has expanded the boundaries of observational astronomy, demonstrated the resilience of interstellar matter, and invited renewed humility in our interpretations. Whatever its nature, it stands as testimony to the complexity of the universe and to our own enduring curiosity. Behind those careful words lay the unspoken truth that every researcher felt. They had witnessed something no one fully understood. It had glowed hotter than the sun's reflection, emitted unknown wavelengths, released nickel vapor without iron, and perhaps whispered once in radio silence before fading forever into the night. And as 3I Atlas vanished beyond the reach of human instruments, the final data packets arrived. Numbers, graphs, timestamps. Within those lines of code, buried somewhere, might still lie an answer waiting to be found. By the middle of 2026, the world had largely stopped talking about 3I Atlas. News outlets had moved on. Research budgets were shifting back to more predictable projects, and most people thought of it as just another comet, a brief visitor that had come and gone. But in laboratories, observatories, and universities scattered across the planet, a smaller, quieter effort was still underway. Hundreds of researchers were re-examining the mountain of data gathered during the object's closest approach. Every signal, every faint photon, every vibration of the radio spectrum was being reanalyzed, refiltered, and compared in ways that hadn't been possible in the first rush of December 2025. It was the slow, patient phase of science, the part that begins when the excitement fades and only the questions remain. At the European Space Agency's Research Centre in Madrid, a small team led by astrophysicist Dr. Emilia Garreau was focusing on one peculiar detail: the persistence of the ultraviolet emission line first detected by the JUICE spacecraft. The line at 304.6 nanometers had defied classification for months. It did not match oxygen, helium, or any known molecular band. Its consistency across multiple instruments and times ruled out error. The emission had remained steady even as the object moved beyond the solar heating zone, far past Jupiter's orbit. Whatever was producing it was self-sustaining. Garreau's team plotted the signal over time and found something new: tiny oscillations in its intensity occurring roughly every 60 hours. The pattern wasn't random. When converted into a frequency domain, the oscillations created a series of evenly spaced peaks, a harmonic pattern, as if the energy output was being modulated. At first, the researchers assumed it was instrumental noise introduced by the spacecraft's sensors or the transmission path. But the same harmonic structure, appeared in data from other observatories taken weeks apart. It was faint, buried under layers of noise but unmistakable. The amplitude was regular, the spacing consistent. When the team compared the spacing to rotational data from the comet's brightness fluctuations, they discovered an eerie coincidence. The spacing of the ultraviolet oscillations matched a multiple of the 10-hour brightness pulse cycle observed during December. Somehow, the optical and ultraviolet emissions were synchronized, even months apart, even as the comet drifted far from the sun. That discovery forced everyone to reconsider what they were looking at. A natural object could spin and emit periodically, but a harmonic relationship between two unrelated emissions suggested coordination, an internal order that was difficult to explain. Meanwhile, across the Atlantic, at NASA's Jet Propulsion Laboratory, the radio analysis team continued dissecting the brief hydrogen line signal recorded during the December event. For months they had treated it as an isolated burst, but now they began comparing it with deep background data collected before and after. The engineers noticed a subtle increase in ambient noise near the same frequency, so faint it had been ignored at first. When they performed a long-term spectral average, a repeating sideband pattern emerged. 3 narrow peaks spaced at exact integer multiples of 1.42 gigahertz. The pattern didn't match any natural radio sources. It looked like interference, but from where? There were no transmitters in that part of the sky, no satellites nearby, and no repeat bursts. The structure was static, embedded in the background, as though the source had emitted once and left an echo imprinted across the frequency band. It was a strange concept, but some of the team speculated that the signal's coherence had created a form of resonant scattering in the interplanetary medium. Others proposed that it was merely a processing artifact. Either way, it hinted that the event hadn't been as simple as a burst of random hydrogen emission. There had been structure in it, information, or at least something that resembled it. By August, 3I Atlas was well past Saturn's orbit, heading toward the cold frontier of the outer solar system. It was now more than 1 billion kilometers away, moving steadily outward, a dim speck visible only to the most sensitive instruments. Its apparent magnitude had dropped below 25, making optical tracking nearly impossible. Yet its influence lingered, not in light, but in thought. Conferences were still being held under titles like Interstellar Objects and the Limits of Natural Formation. New mission proposals were being drafted. Plans for faster intercept probes that could study future interstellar visitors before they vanished. For the first time, space agencies were seriously considering how to chase such objects, not merely observe them. 3I Atlas had shown that these visitors could carry data older than the solar system itself, and perhaps something else entirely. Then, in early September, something unexpected happened. The Atacama Large Millimeter Array, ALMA, in Chile, which had been periodically scanning regions of deep space for calibration, detected a faint millimeter wave reflection from the direction of Atlas's predicted position. It wasn't strong enough to resolve structure, but it was there, a cold echo of the object still reflecting microwave energy months after leaving the inner solar system. More interestingly, the reflection's polarization angle was slightly rotated compared to background sources. That meant the object was interacting with magnetic fields in a unique way, possibly through a residual plasma envelope or a metallic surface capable of Faraday rotation. Natural perhaps, but not ordinary. As data accumulated, the scientific world began to divide into 2 broad camps. The first argued that 3I Atlas was a natural body, albeit an extraordinarily rare one, formed under extreme conditions in the early universe. They believed that time, radiation, and interstellar chemistry could produce unusual ratios of nickel, unknown spectral lines, and exotic magnetic properties. The second camp, smaller but growing, suspected that not all of Atlas's behavior could be explained without invoking some form of artificiality. To them, the harmonic oscillations, coherent radio burst, and geometrical surface patterns hinted at a design too consistent to be random. Neither side could prove the other wrong, and the argument became less about data and more about interpretation. Through it all, one question kept surfacing in public and private discussions alike. If it was artificial, then who built it, and when? The implications were staggering. If 3i Atlas truly was a machine, it must have been constructed by a civilization older than the Earth, older even than the Sun. 10 billion years of travel meant that its makers had lived in an era when galaxies were still forming. They might have been the first intelligence the universe ever produced, and perhaps the last remnants of their existence were drifting silently through interstellar space, powered by ancient energy systems that still functioned long after their creators were gone. In October 2026, a consortium of research institutions released the most comprehensive study yet, an 800-page document compiling every observation, measurement, and hypothesis related to the object. The report was neutral, but between its lines was the quiet recognition that 3i Atlas didn't fit comfortably into any known category. The data on its thermal emissions, chemical composition, and light polarization remained anomalous. Its resilience through the sun's furnace remained unexplained. The brief hydrogen line transmission was confirmed as real but unrepeatable. The document concluded with a single line that captured the mood of the entire community. 3i Atlas reminds us that we have not yet reached the limits of what nature, and perhaps intelligence, can create. Outside the world of academia, the comet's legend had taken on a life of its own. Documentaries called it the visitor beyond time. Artists painted it as a messenger between galaxies. Online communities speculated about its purpose, inventing theories that ranged from reasonable to fantastic. Some saw it as an ancient probe sent to record stellar births. Others imagined it as a derelict ship, its purpose forgotten, its systems still running on automatic cycles after eons. A few more poetic voices compared it to a seed, a fragment cast into the void, waiting for new suns to awaken it. Whatever the truth, it had become part of human culture, a modern myth rooted in measurable fact. But among the scientists who had lived with the data, there was no myth, only the weight of uncertainty. In December 2026, a year after the closest approach, NASA quietly published a final technical paper summarizing the last confirmed detections. The ultraviolet emission had finally faded below detectability. The thermal hotspot, long vanished, from Webb sensors had never returned. The object was now nothing more than a point on a trajectory chart, a silent wanderer receding into the dark. Yet within the closing paragraph of that report was one final observation that went almost unnoticed at first. The last recorded pulse sequence from December 2025 exhibits a phase drift over time, consistent with precession of a stabilized rotating body. In simple terms, that meant the object might have maintained its orientation through some stabilizing mechanism, something that resisted random tumbling over long periods. That detail, small and technical, reopened every question. Natural comets and asteroids do not self-stabilize. Their rotations are chaotic, altered by gas jets and impacts. But 3i Atlas's rotation had remained nearly constant through its entire visible journey. The drift observed was too regular, too slow, more like controlled precession than random spin decay. If that was true, then even after all the careful neutrality of scientific language, the evidence was pointing toward one unsettling conclusion. Whatever 3i Atlas was, it behaved as if it were built to last. As the second winter of the story settled in, the object slipped beyond the reach of every telescope. Its trajectory carried it into the deep freeze of interstellar space, where sunlight dwindled to a faint whisper. The last radio pings from the Deep Space Network confirmed its speed and heading, then silence. It would take centuries before it crossed another star's boundary, if it ever did. In that silence, humanity was left to interpret meaning from absence. The greatest discoveries often come not from what is seen, but from what remains unexplained. 3i Atlas had shown that the universe still contained mysteries untouched by human logic. Whether it was a relic of nature or technology, it had reminded the world that reality could still outpace imagination. It left behind no answers, no messages, only data, faint echoes, and a sense of scale that dwarfed human comprehension. Somewhere beyond the orbit of Neptune, an object forged before the Earth was born continued its endless voyage. Its surface carried scars of ancient heat, traces of metal that glimmered once in the light of a borrowed sun. It would drift onward through the emptiness for billions more years, indifferent to the curiosity it awakened. Perhaps, in some distant age, another civilization would find it and ask the same questions we ask now. Perhaps they too would wonder if someone had been here before them, leaving behind a silent testament that intelligence had touched the stars once and would again. For now, on our small planet circling a single ordinary star, the story of 3i Atlas remained both complete and unfinished. Complete because the object was gone, unreachable. Unfinished because every answer it might have carried was locked inside its metallic core, still pulsing faintly in the cold dark. Its passage had changed nothing material, yet it had changed everything about how we see ourselves. Fragile beings staring into the void, waiting for meaning, aware for the first time that the universe might already have spoken, and that we might have only just begun to listen. By the beginning of 2027, 3i Atlas was nothing more than a line of numbers on a computer screen, a distant speck of mathematical certainty racing toward interstellar space. The world had returned to its usual rhythm, but in a handful of observatories, research institutions, and university basements, the investigation had never stopped. The fascination persisted, not in the public imagination, but in the minds of those who had seen the data firsthand. For them, 3i Atlas was unfinished business, a riddle left unsolved, a phenomenon that had resisted every reasonable explanation. The official reports were published, the budgets closed, but curiosity, once ignited, doesn't obey administrative deadlines. At NASA's Goddard Space Flight Center, an archival project was underway to preserve all 3i Atlas data in a single unified format. It was meant to be an act of closure, a digital time capsule for future researchers. But the process of consolidating the data unearthed something unexpected. During cross-verification of timestamp logs from the Deep Space Network, a software engineer named Michael Reyes noticed a tiny discrepancy. The recorded timestamps of the 142 GHz radio burst were misaligned by exactly 0.072 seconds between three observatories. Normally, such timing variations would be dismissed as equipment latency or atmospheric interference. But the offsets weren't random. They formed a perfect sequence, each observatory's signal delayed by a uniform increment proportional to its longitude. Reyes wasn't an astronomer, but he was a mathematician by training, and he recognized the pattern as deliberate, not coincidental. If the delay had been caused by transmission distance, the differences would have been irregular. Instead, they followed a linear progression, an encoded interval. He ran a simple test, normalizing the delays and converting the time offsets into binary by representing each interval as a 1 for longer and 0 for shorter durations. When he graphed the resulting bit stream, it wasn't noise. It formed a recurring 17-bit pattern that repeated 3 times across the burst. He thought it might be compression artifacts or data jitter, but when he cross-checked it against background signals from the same night, none showed similar structure. The pattern only appeared within the 90-second window of the hydrogen line event. Reyes didn't claim it was a message. He wasn't sure what it was, but he flagged the finding in the internal NASA database. For weeks, nothing happened. Then, one of the SETI analysts reviewing legacy data noticed Reyes's annotation and ran a Fourier analysis on the bit stream. The pattern produced a harmonic resonance curve strikingly similar to the spectral peaks of the ultraviolet oscillations recorded by the JUICE spacecraft months earlier. The two datasets, radio and ultraviolet, were entirely separate in time, space, and wavelength, yet they shared the same frequency ratio of 5.3. Statistically, the odds of such correlation arising by chance were infinitesimal. The scientists didn't announce it publicly. They understood what it implied, but weren't ready to confront it. Instead, they circulated a confidential memo under the title Potential Cross-Spectrum Correlation between UV emission and hydrogen line burst. The language was measured, but the conclusion was staggering. The radio burst and the ultraviolet oscillations appeared to be synchronized manifestations of the same underlying process. Meanwhile, the European Space Agency's data center in Darmstadt was running long-term simulations of the comet's trajectory. Their models, refined with the latest gravitational data, showed that Atlas's path deviated ever so slightly from a purely ballistic orbit. It wasn't enough to be considered propulsion, just a tiny, steady drift, smaller than any active thrust we could detect. But it was real. When the analysts extrapolated backward, they found that the deviation began immediately after the object's passage behind the Sun in late 2025. From that point onward, it had been accelerating outward at a rate of roughly 2 millimeters per second squared, minuscule but measurable. The official explanation labeled it non-gravitational acceleration, likely due to asymmetric outgassing. Yet that same reasoning had once been used to explain the odd acceleration of Oumuamua, a justification that never fully convinced anyone. For those still following the mystery, the pieces were aligning into an uncomfortable picture. The ultraviolet modulation, the coherent radio pulse, the rotation stability, and now the persistent outward drift, all hinted at an internal mechanism still active, still functioning long after the object had left the warmth of the Sun. The question was no longer whether Atlas was anomalous. It was how anomalous it truly was. At the University of Cambridge, astrophysicist Dr. Lenora Brooks, whose earlier paper had described Atlas as a fragment of a planetary core, was among the first to reconsider her position. She had spent much of 2026 defending the naturalist view, but by early 2027, she had begun to entertain another possibility. In a private lecture recorded for her graduate students, she proposed that Atlas might not be a single solid body at all, but a composite shell, a hollow structure containing dense material that could act as both heat source and stabilizer. Such configurations could form naturally under extreme conditions, she explained, but they could also be engineered for endurance. Her final slide contained a phrase that summed up the growing ambiguity surrounding the entire subject. The line between the natural and the artificial is defined by what we can't yet explain. While academics debated theory, a parallel effort was unfolding among independent data analysts. A consortium of volunteer researchers, many of them programmers, radio amateurs, and physicists, had organized an open-source initiative called Project Echo. Their goal was to replicate all known analyses of 3I Atlas data and test alternative interpretations. Using publicly available information, they reconstructed the radio burst waveform, reprocessed optical light curves, and created simulated models of possible signal encoding methods. What they found deepened the intrigue. When they applied a time compression algorithm to the 90-second radio burst, the frequency modulation appeared to contain substructures, brief shifts resembling phase changes. To the naked eye, it looked like faint Morse code. When one of the coders plotted the modulation sequence into a visual spectrogram, the pattern resolved into a simple geometric shape, a pair of intersecting arcs forming a kind of ellipse. It might have been coincidence, a byproduct of digital filtering. But to those who wanted to believe, it looked deliberate. As more independent researchers joined, the discussion spilled into online forums and digital journals. For the first time, the once restrained conversation about potential artificiality became mainstream again. NASA and ESA issued no official comments, but a few scientists quietly confirmed that internal investigations were still active. In late March 2027, An anonymous source within the European Space Agency leaked a snippet of an internal document confirming that persistent low-frequency emissions have been intermittently detected from the 3I Atlas trajectory line through February 2027. The signal was faint, almost indistinguishable from background noise, but statistically significant. If true, it meant the object was still emitting something, long after it should have gone inert. By April, the public once again turned its eyes toward the stars. Media outlets revived the story, calling Atlas the ghost probe, a poetic term that resonated with audiences who remembered the original headlines from 2025. Documentaries revisited the timeline, from its arrival to its mysterious disappearance, weaving the new data into narratives that blended science with speculation. For the first time, people began to wonder not only where Atlas came from, but whether it had noticed us. Amid the renewed attention, NASA convened a private symposium in Washington, D.C. The topic was officially listed as Interstellar Object Data Analysis. But behind closed doors, the conversation turned philosophical. A retired astrophysicist named Dr. Stephen Krall posed a simple but disquieting question. If it was built, then who built it, and why would it come here? He wasn't asking rhetorically. He had spent months studying the trajectory data and concluded that Atlas's entry into the solar system wasn't random. Its path through the ecliptic, its near alignments with Mars and Venus, and its final approach behind the Sun formed a geometric pattern almost too precise to be coincidence. He proposed that the alignment itself could have been intentional, an observational strategy, perhaps a survey route designed to gather information from multiple gravitational bodies before departing. The idea was speculative, but it explained the otherwise improbable orbital precision. His conclusion was quiet, almost resigned. If this was a probe, then it wasn't here to make contact. It was here to look. That notion, of a silent observer passing through our system without interaction, haunted those who heard it. It fit the evidence. No communication, no deviation, no visible activity beyond what was necessary for its function. If it had been a machine, it was one built for patience, a device designed to endure eons, awaken briefly to refuel or recalibrate, and continue its eternal mission. In that sense, 3I Atlas wasn't a messenger at all. It was a witness. By summer 2027, Project Echo had released a public report summarizing its findings. It didn't claim alien origin or technology, but it highlighted patterns too structured to ignore. Harmonic synchronization between ultraviolet and radio frequencies, coherent signal envelopes, precise timing offsets, and the absence of random noise typical of natural events. The report ended with a line that captured the shared sentiment of the entire scientific community. We may not yet know what 3I Atlas was, but we know it was something extraordinary. Meanwhile, deep within the archives of the European Southern Observatory, another discovery was made, one that would take months to reach the public. A graduate student named Elena Kovac, tasked with calibrating spectral reference files, stumbled across unused frames from December 19, 2025, originally discarded due to overexposure. When she adjusted the brightness curves to recover faint detail, a peculiar gradient appeared along the edge of the coma. It looked like faint, radial streaks, evenly spaced and converging toward the nucleus. Using modern reconstruction algorithms, she enhanced the image further, revealing something astonishing. The streaks were not random. They formed concentric rings, subtle, symmetrical, and repeating. At first, her supervisor dismissed it as a lens artifact, but when other observatories' data from the same day were cross-checked, the rings appeared there too, faint but consistent. Each ring was separated by the same angular distance. The structure wasn't visible before perihelion, nor after. It existed only during the brief window when Atlas was closest to the Sun. If it were natural, it was unlike any known dust or gas ejection pattern. If it were artificial, it might have been the visible trace of an energy field, a containment structure, a cooling shell, or something far beyond our technology. By autumn 2027, 3I Atlas had passed beyond the heliopause, leaving the domain of the Sun entirely. Its speed, relative to the Milky Way, now matched the background flow of interstellar matter, a sign that it had returned to the vast migration of cosmic debris, or perhaps resumed a planned trajectory toward its next destination. It was officially gone, beyond tracking range, beyond reach. Yet the data it left behind continued to echo through scientific journals, university lectures, and the imaginations of millions. The final consensus, if it could be called that, emerged slowly. The object was never proven to be artificial. No message, no signal, no maneuver confirmed intent. And yet, neither was it convincingly natural. It existed in the space between categories, a reminder that the universe is under no obligation to conform to human expectations. In the end, perhaps that was its greatest revelation, that our definitions of natural and artificial are temporary conveniences, boundaries drawn across the unknown. As the years moved on, 3I Atlas became less of a mystery to solve and more of a story to remember. It taught a generation of scientists humility. It inspired new missions designed to intercept future interstellar objects before they vanish. It reignited interest in SETI and the search for non-biological intelligence, and it quietly reshaped how humanity thought about time, endurance, and legacy. Somewhere, far beyond the reach of light, the object continued its silent journey. Whatever intelligence, if any, had once set it in motion was long gone, but its purpose endured. Perhaps it was simply doing what it had always done, observing, recording, waiting. And if one day, countless years from now, another civilization finds it drifting through their skies, they may wonder the same thing we did. Who built it? Why did it come here? What happened behind the sun? Until then, it remains what it always was, an echo across the stars, a question without an answer, a reminder that even in the age of technology and certainty, there are still moments when the universe looks back at us and says, "You don't know me yet." By the year 2028, the name 3I Atlas had become legend within the scientific community, an emblem of unanswered questions. To most of the public, it was already fading into the background of memory, another headline from a busier decade. But for scientists, engineers, and dreamers, the mystery had evolved into something larger. It wasn't just about one object anymore. It was about what its visit had awakened. Humanity, for the first time, truly felt the scale of interstellar possibility. If something that ancient, that resilient, could cross the darkness between stars, then so could we. In the aftermath of Atlas's departure, dozens of proposals for new interstellar programs began appearing in research institutions worldwide. The Interstellar Research Initiative was founded in early 2028, pooling resources from NASA, ESA, JAXA, and several private aerospace companies. Its mission was straightforward in words but audacious in ambition: to prepare for the next encounter. The question was no longer if another interstellar visitor would come. It was when. And this time, humanity would be ready to intercept it before it disappeared into the void. The first phase of the initiative focused on data. Teams revisited every observation of Atlas, Oumuamua, and Borisov, seeking patterns that might predict the trajectories of future interstellar travelers. Algorithms scoured archival sky surveys, identifying dozens of faint objects that might fit the profile of incoming extrasolar bodies. For every false positive, another potential candidate emerged. The search itself became a new discipline: interstellar forensics, the art of finding messages written in motion. The scientists who once chased the comet's fading glow now combed through terabytes of sky imagery, looking for hints of movement too subtle for earlier generations to detect. By mid-2028, a new proposal was approved: Project Helioscope, a fleet of miniature solar sail probes designed to station themselves around the inner solar system. Their purpose was to detect, photograph, and, if possible, intercept interstellar objects as they passed near the Sun. Unlike traditional spacecraft, the helioscope probes would be propelled entirely by sunlight, allowing them to maneuver quickly without fuel. The design itself was inspired by Atlas. The same metallic resilience, the same endurance. It was poetic, a mystery giving birth to technology. Humanity was imitating what it couldn't yet understand. Meanwhile, debates continued in the academic world. The most controversial papers weren't about trajectories or spectroscopy, they were about philosophy. What did it mean to find an object that might have been built before the Earth formed? Could intelligence, once born, leave traces that outlive even its creators? Astrobiologists began to shift focus from searching for life to searching for artifacts, physical relics of past civilizations scattered through the galaxy. It was a subtle change, but it marked a new phase of human exploration. The universe was no longer just a field of biology waiting to be discovered. It was a museum of forgotten technologies waiting to be recognized. At the same time, small but significant developments began to reshape how humanity looked outward. In 2029, the Eventide Array, a network of optical and infrared telescopes spanning Chile, South Africa, and Australia, began continuous scanning of the ecliptic plane. The array's purpose was to detect faint moving points that entered the solar system from interstellar space. Its first operational year yielded no discoveries, but the mere act of constant watching changed the psychology of exploration. Humanity was no longer waiting passively for the unknown to appear. It was listening for it. As new generations of scientists entered the field, they inherited both the mystery and the humility of the Atlas story. It became a touchstone for young astronomers, the perfect reminder that certainty is the enemy of discovery. University students studied the archived data as a rite of passage. The radio burst, the ultraviolet line, the harmonic oscillations, all became puzzles they would try to explain anew. Every few years, a new analysis would claim to have found the final answer, only for another study to dismantle it. The object had left, but its shadow remained in every discipline it touched. In 2030, the International Astronomical Union declared the decade of 2030-2040 the interstellar decade. It was both a celebration and a challenge, a recognition that for the first time, humanity possessed the technology to reach beyond the solar boundary. The declaration coincided with the approval of a long-range probe design called Asterion, a hybrid between a solar sail and a nuclear electric engine. Asterion would travel faster than any human-made object in history. Its mission: to intercept the next interstellar body within months of detection. It was a technological marvel, but its existence was also a confession. Humanity had learned from Atlas that some answers can't wait decades. While governments debated funding, a quieter revolution was happening in the private sector. Several aerospace startups began to focus on long-duration autonomous systems, machines designed to operate for centuries without human intervention. Their engineers openly admitted their inspiration. "If 3i Atlas could last 10 billion years," one founder said, "we should be able to build something that lasts 10,000. The idea spread. Longevity became the new frontier. Spacecraft were now being designed not just to reach destinations, but to outlive civilizations. And yet, even as humanity turned its gaze toward the stars, the data from Atlas still whispered in the background. In late 2031, an independent researcher at the University of Helsinki made an intriguing discovery while revisiting the old ultraviolet datasets. When reprocessed using machine learning noise reduction algorithms that hadn't existed in 2026, the harmonic pattern of the emission became clearer. The oscillations appeared to contain amplitude modulations corresponding to prime number intervals 2, 3, 5, 7, 11. By early 2035, the world had entered a quiet tension, an almost sacred anticipation that felt like standing on the edge of something vast. For nearly a decade, humanity had waited for this moment, tracing faint dots of light across digital skies, running endless simulations, dreaming about the return of the unknown. And now it was happening again. 4I Prometheus, the newest interstellar object, was entering the inner solar system, following a trajectory so eerily similar to that of 3I Atlas that it seemed scripted by fate. Every major observatory on Earth, every orbital telescope, and every sensor array was pointed at it. Even before it could be seen with the naked eye, the data began to arrive, sharp, cold, and undeniable. The object was long, slender, and astonishingly smooth. The first radar readings from the Goldstone Deep Space Complex revealed that Prometheus was approximately 800 meters in length, but barely 100 meters across, reflecting radar pulses far more efficiently than any known asteroid. Its surface was uniform, lacking the jagged contours of natural rock. When the James Webb Space Telescope turned its gaze toward the object, it captured something even stranger. The spectral data indicated that Prometheus's outer layer wasn't metal or ice. It was something in between. It reflected visible light like polished alloy, but absorbed infrared radiation almost perfectly, behaving like a thermal mirror. That single discovery sent shockwaves through the astrophysics community. No natural material known to science had those properties. Within weeks, the theories began multiplying. Some claimed it was a fragment of a planet's crust, crystallized under extreme pressure. Others speculated that it might be a sliver of a neutron star ejected during a supernova. But a growing number of voices whispered what everyone else feared to say aloud. What if it wasn't natural at all? The word artifact began appearing again in research drafts, cautiously bracketed in quotation marks. The Asterion probe, humanity's first true interstellar interceptor, was already en route by then, a gleaming sail of graphene-reinforced film gliding across the solar wind. Launched in 2034 and accelerated by laser propulsion arrays from Earth's orbit, it was the fastest human-made object ever built. It would reach Prometheus in October 2035, just as the object made its closest approach to the Sun. Engineers and mission planners called it the Second Encounter, though privately many referred to it as the Reckoning. Humanity was about to meet its second visitor, and this time we would not just watch it pass. As Prometheus drew nearer, new details emerged. Unlike Atlas, it emitted no coma, no gas jets, no visible outgassing at all. It was completely inert. Its light curve, however, revealed a slow, deliberate rotation, once every 12 hours, perfectly stable. No sign of tumbling, no variation in spin rate. This stability, too, was suspicious. Natural bodies rarely maintain such precision. They wobble, drift, and precess under the pull of solar tides. Prometheus rotated like a balanced spindle. It was as if it wanted to remain oriented a certain way. By May, the Asterion mission control team at JPL received its first long-range optical images of the target. The pictures were grainy, low resolution, but unmistakably artificial-looking. The object's edges were straight, not curved. It had facets, flat, planes that reflected sunlight in sharp, discrete flashes. Analysts debated whether they were merely coincidental alignments of reflective material or true geometric surfaces. But when the probe captured the first laser altimetry map in late June, the argument ended. The topography data revealed a series of repeating ridges running along the object's length, evenly spaced like ribs in a vast, ancient structure. To many, the realization was almost unbearable. Humanity had spent centuries searching the skies for evidence of intelligence, only to find it in the form of a relic drifting silently through the dark. What made it more haunting was its silence. No signals, no emissions, no heat signatures beyond solar reflection. If it was a machine, it was long dead or waiting. By August, the object passed inside Earth's orbit, becoming visible in the pre-dawn sky as a faint silver line near Venus. Amateur astronomers captured its movement across the stars, some describing it as unnervingly deliberate, as if its trajectory had intent. The media exploded. Every major network on Earth ran continuous coverage of Prometheus's approach. Headlines shouted variations of the same question. Was 3i Atlas just the beginning? The Asterion probe continued its approach, broadcasting constant telemetry back to Earth. Inside its polished sail, the onboard AI, nicknamed Lyra, processed navigation corrections with minimal human input. It had been designed for autonomy, capable of functioning independently if contact was lost. Its final mission directive was simple: observe, document, and survive as long as possible. Unlike past missions, there would be no physical samples, no landing attempt, just proximity and observation. Humanity was not yet ready to touch the unknown. On September 19, 2035, at 03:14 UTC, Asterion crossed the million-kilometer mark. Prometheus filled its forward cameras, a dark, blade-like form cutting through the void. The sunlight scattered across its surface in narrow bands, revealing patterns too intricate to dismiss as random. There were grooves, depressions, and faint traces of symmetry. The probe's spectrometer registered a thin layer of carbonized material coating the object, suggesting immense age, perhaps millions or billions of years. Beneath that, however, the density profile hinted at a lattice, structured, repeating, not crystalline. The data stunned mission scientists. It was a geometry within geometry, a design beyond comprehension. Then, something happened. At exactly 0409 UTC, as Asterion passed within 800,000 kilometers, its magnetic field sensors detected a sudden surge, a pulse of low-frequency radiation lasting 3 seconds. It was faint but undeniable, like the heartbeat of something ancient awakening after eons of silence. The pulse repeated once more, then ceased. It carried no modulation, no information, just a raw electromagnetic throb. But it was enough. The probe's sensors recalibrated automatically, registering the anomaly as unclassified energy emission. On Earth, the news reached mission control 12 minutes later, delayed by transmission lag. The room went silent as the waveform appeared on the screen, a smooth, symmetrical curve identical to the radio burst recorded from Atlas 10 years earlier. The same shape, the same frequency pattern, the same signature. The realization was immediate and electrifying. These two objects, separated by time and space, were connected. Whatever 3i Atlas had been, Prometheus was its sibling. The pulse repeated again 6 hours later, timed perfectly to the object's rotation period. It was no accident. Whether the emission was a malfunction, a natural reaction, or a deliberate signal, no one could say. But for the first time in history, humanity was observing an event not once, but twice. The universe was repeating itself, and it was watching. As the probe approached its closest distance, just 250,000 kilometers away, it activated its LiDAR system to map the object's surface in full three-dimensional detail. The resulting images revealed a central ridge running almost the entire length of Prometheus, bordered by parallel grooves that spiraled gently around it. The pattern resembled both engineering and ornamentation, a fusion of form and function. At the equatorial midpoint, a large depression appeared, nearly circular, smooth-edged, and shallow. It looked like a hatch or a lens. Asterion's onboard AI focused its cameras on that region and began continuous imaging. Over several rotations, it recorded faint flickers of light from within the depression. Flashes so brief they could have been reflections, but they were consistent, rhythmic, repeating every 12 hours. When the data was transmitted to Earth, analysts discovered that the flickers matched the timing of the electromagnetic pulses. The object was emitting and reflecting in synchronization, a dual heartbeat of light and magnetism. Governments around the world went into quiet emergency meetings. NASA and ESA coordinated statements, assuring the public that the phenomenon was under study and consistent with natural processes. Few believed it. The leaked imagery spread online, and soon the world was caught between awe and fear. Some saw Prometheus as a herald, others as a warning. The more rational voices called for patience, urging that interpretation must follow evidence. But the evidence itself was already beginning to rewrite reality. On October 3, 2035, at 11:27 UTC, the unthinkable occurred. As Asterion prepared for its final flyby, passing within 100,000 kilometers, every sensor aboard the probe went dark for exactly 60 seconds. Telemetry ceased, cameras blacked out, and the sail's gyroscopes froze. Then, as abruptly as it had stopped, the signal returned. The probe was undamaged, its systems intact. But in those missing 60 seconds, something impossible had happened. When the mission team reviewed the recovered data, they found that the probe's atomic clock had advanced by 0.34 seconds relative to synchronized ground stations. That discrepancy was too large to be a system error and too small to be a transmission glitch. It was as if time itself had stretched. Engineers proposed a dozen theories: electromagnetic interference, solar flare distortion, relativistic correction, but none fit the timing or directionality. The blackout occurred precisely when Asterion crossed behind Prometheus relative to the Sun, the same position where 3I Atlas had once released its own mysterious emission. Whatever was happening behind the Sun a decade earlier was happening again, this time with us watching. When contact stabilized, Asterion transmitted one final packet of data, a compressed burst of high-resolution images taken just before the blackout. Among them was a frame showing Prometheus's central depression in extraordinary detail. Within its smooth basin was a faint pattern, lines etched into the surface, forming concentric shapes. When enhanced, the lines revealed symmetry resembling spirals or glyphs. No one dared call it writing, but it bore the unmistakable precision of design. That image became one of the most analyzed in human history. Scientists debated endlessly, were the markings natural fractures or remnants of fabrication? Were they symbolic or purely mechanical? For months, the debate consumed academia, media, and philosophy alike. Humanity had wanted answers, and it had received only deeper mystery. By November 2035, Asterion had completed its flyby and begun its long drift into deep space. Its sail, once bright and taut, now turned away from the Sun, carrying the probe outward with the faintest push of light. The mission was officially declared a success, though no one could define what success meant anymore. We had seen the surface of something beyond comprehension, recorded its pulse, and witnessed its silence. Prometheus, meanwhile, continued its orbit, passing behind the Sun in December. When it emerged again weeks later, it had changed. Its reflectivity had diminished. The sharp, clean glint of its surfaces had dulled, as if coated by dust or shadow. Yet its trajectory remained precise, its rotation steady, its silence unbroken. It sailed past Earth's orbit one final time and began its slow retreat into the outer darkness, leaving behind a trail of electromagnetic residue detectable only by the most sensitive instruments, a faint whisper fading into the cold. For humanity, the encounter marked a turning point. The two visitors, Atlas and Prometheus, had defined an era, a twin enigma written across 20 years of human history. One had come before we were ready. The other arrived when we finally had the means to follow. Together, they formed a pattern. Two artifacts, two alignments, two pulses behind the Sun. It was as if the universe were teaching in repetition, waiting for its students to notice the lesson. As 2036 dawned, astronomers began to speculate. If two had come, could there be more? The question wasn't rhetorical anymore. Observatories resumed their watch, scanning every corner of the sky. For the first time, humanity's vigilance wasn't born of fear, but of recognition. We had glimpsed something vast, a network perhaps, or a legacy scattered across the stars. And somewhere beyond Neptune, Three-Eye Atlas and Four-Eye Prometheus travelled parallel courses, two silent fragments of the same ancient origin. Whatever they were, they had both turned their faces to the same sun and then moved on. Maybe, in the endless distances between stars, they would meet again. By 2036, the shock of Prometheus's passing had settled into something more profound, a collective stillness that reached deeper than awe. It was the silence of realization. Humanity had looked upon two visitors from beyond the stars and come away with nothing it could fully explain, nothing it could claim to understand, and nothing it could deny. The data, the patterns, the pulse behind the sun, all pointed toward a truth that remained maddeningly just out of reach. The scientists called it non-conclusive evidence. The public called it the beginning. For the first time in living memory, the human species felt itself observed not metaphorically, but literally. When Prometheus disappeared into the black, the world did not return to normal. Something in our collective psyche had shifted, a subtle change that would ripple through the rest of the century. Governments quietly increased funding for deep space observation. Private companies formed coalitions to develop autonomous probes, and new universities opened departments devoted entirely to exo-engineering, the study of non-terrestrial design principles. Every new satellite, telescope, or mission was measured against the two objects that had defied our understanding. Humanity was no longer waiting for discovery. It was preparing for recognition. In early 2037, the Asterian Data Archive was released in full to the scientific community. The images of the etched concentric spirals on Prometheus's surface were studied, filtered, and reinterpreted through every imaginable lens: geological, thermodynamic, even semiotic. Nothing fit perfectly, but one pattern stood out. The spacing of the spirals followed the Fibonacci sequence, the mathematical ratio found everywhere in nature, from seashells to galaxies. This discovery sparked a cultural explosion. Was it proof of design? Was it coincidence? Artists, philosophers, and mathematicians argued for months. Some claimed it was simply a universal structure, nature's default blueprint. Others whispered that such precision on such an ancient object was a signature, a cosmic calling card left by minds that understood the language of the universe better than we did. At the same time, a smaller group of scientists began focusing on something overlooked: the background radiation during Asterian's communication blackout. When analyzed with new quantum signal filters, the noise revealed subtle peaks spaced at uniform intervals, identical to the ultraviolet oscillations of Three-Eye Atlas. It was faint, barely measurable, but statistically significant. The implication was staggering. Both objects had emitted the same underlying frequency pattern even years apart. The phenomenon was given a name: the Atlas-Prometheus resonance, and it became the most studied signal in modern astrophysics. Throughout 2037, the resonance dominated scientific conferences and headlines alike. One theory proposed that it represented a form of cosmic handshake, a self-checking communication signal that only becomes meaningful when observed from 2 points in space and time. According to this model, each object emitted half of a message, a data structure so vast that it required multiple encounters to decode. If true, it meant that the story wasn't over, that the universe might still be speaking, slowly, in fragments scattered across centuries. In the same year, the SETI Coordination Council restructured its mission. It shifted from passive listening to active analysis, merging with astrophysical observatories to create a global data grid capable of recognizing patterns across decades. The system was designed to detect anomalies, not words, a listening net woven through radio, light, gravity waves, and even neutrino data. Its mandate was simple: if the next visitor came, the world would not be caught unprepared. But beyond the laboratories, the echoes of Atlas and Prometheus were changing something more intimate: the way humans thought about themselves. Religions reinterpreted their doctrines. some claiming that the visitors were divine instruments, others rejecting the idea entirely. Philosophers debated whether contact, if it ever came, would erase the meaning of human existence or fulfill it. Writers filled shelves with stories of civilizations communicating through relics of metal and silence. Humanity had entered a new mythic age, one where faith, science, and wonder intertwined once more. In 2038, a breakthrough came from an unlikely source. A group of quantum physicists at the University of Sydney, analyzing the magnetic data from Asterian's instruments, found that during the probe's 60-second blackout, its gyroscopic orientation shifted by a measurable angle, 0.004 degrees, before returning to its original alignment. The movement was microscopic, but it wasn't random. It aligned perfectly with Prometheus's magnetic field vector at the moment of the blackout. The findings suggested that the probe had experienced a controlled external influence. Not interference, not collision, but interaction. Something had momentarily touched it at a distance, as though space itself had bent around the machine. The paper describing the discovery was titled "The Contactless Event." The world reacted in waves. Some dismissed it as overinterpretation, but others saw it as the first tangible sign of communication. Not words, not images, but gesture. The universe, it seemed, spoke not in sound, but in physics. By 2039, new missions were in motion. Asterian 2, equipped with enhanced quantum field sensors, was already in development. Its purpose? To rendezvous not just with future interstellar objects, but with anything resembling the Atlas Prometheus profile. The blueprint included autonomous self-repair systems, a self-sustaining fusion microreactor, and long-term AI capable of reasoning beyond human directives. The mission planners referred to it as the listener. It would not transmit. It would only observe and wait. Yet as the future accelerated, humanity's gaze turned backward again. In reanalyzing the archived sky data from the late 20th and early 21st centuries, researchers found faint objects previously ignored, possible candidates for ancient interstellar passers-by that had gone unnoticed. The thought that others had come before, perhaps millions of years earlier, unsettled even the most rational minds. Were these visitors part of a sequence, a constellation of drifting monuments scattered across the Milky Way? And if so, were they wandering relics or deliberate beacons? By 2040, humanity's scientific frontier had become an act of collective introspection. The search for intelligence beyond Earth was no longer about looking outward. It was about learning how to recognize intelligence when it hides within silence and time. We had learned that technology, when it endures long enough, becomes indistinguishable from geology. The stars themselves might be archives. The comets might be servers. The dust between systems might carry the ashes of civilizations long gone. That same year, a new generation of thinkers, scientists, linguists, and AI theorists formed the signal theorists, a group that approached Atlas and Prometheus not as phenomena, but as language. They believed that the patterns observed in both visitors were not mechanical artifacts, but intentional constructs meant to encode universal constants, hydrogen frequencies, orbital ratios, Fibonacci harmonics, the alphabet of physics itself. To them, the two objects were not random. They were the first syllables of a story spoken by a civilization that understood the universe not as matter, but as message. The movement spread. Universities offered courses in exolinguistics. Governments quietly debated the ethics of replying, if, indeed, there was something to reply to. For the first time, humanity faced the possibility that the universe was not empty but already written, and that we had simply not learned how to read. Then, in mid-2041, something happened that would redefine everything once more. During a routine calibration of the Eventide array, operators detected a faint but structured radio pattern coming from the outer solar system. It was weak, barely above noise level, and it lasted less than a minute. When analysts cross-checked the data, They realized that the signal's frequency was exactly halfway between the Atlas and Prometheus emissions. It was not from either object. It originated from a region just beyond Neptune's orbit, an area of space thought to be empty. Within days, observatories across the world confirmed the finding. The signal was real, and it repeated once every 240 hours, 10 days exactly, the same base cycle as the pulse interval of 3I Atlas. The pattern was simple: a rising tone, a pause, a falling tone. No modulation, no data packet, just a rhythm. Yet the implications were earth-shattering. If the signal wasn't natural, and few believed it was, then something within our own solar system was now active. The media called it the third whisper. For the scientists who had spent decades chasing echoes of the first two visitors, the discovery felt inevitable. The resonance had returned, not from interstellar space, but from home. It was as if the two wanderers had left behind a seed, a remnant, or perhaps a relay waiting in the cold outskirts of the sun's domain. The eventide array recalculated the coordinates, narrowing the source to a region within the Kuiper belt, near a cluster of dark, slow-moving objects. Within weeks, a probe mission was approved, Project Eidolon. Unlike the Asterian probes, Eidolon would be built for persistence. It would not merely pass by the anomaly. It would remain there, orbiting, listening, learning. Engineers joked that it was humanity's first embassy to the unknown. But beneath the humor was a deep and sober truth. For the first time, we were sending not explorers, but witnesses. And as preparations began, an unease spread quietly through the scientific community. 2 visitors had come and gone. A third signal now hummed in the dark, waiting. The pattern was undeniable. The solar system was not just a destination. It was a node in something far larger. As 2042 dawned, the words of an anonymous scientist circulated across encrypted research networks. Perhaps they were never probes, perhaps they were markers, and perhaps they are not waiting for us to find them, but for each other. That thought lingered, hauntingly plausible. Somewhere beyond Neptune, in the frozen blackness, something waited, steady, patient, and ancient. Its rhythm pulsed faintly against the cosmic background, as if keeping time with the slow heartbeat of a universe that had been alive long before us and would remain so long after. By late 2043, the Eidolon probe left the orbit of Neptune, gliding into the cold abyss where sunlight weakens into starlight and the solar wind fades into interstellar calm. For the scientists at Mission Control, it was a moment both historic and unsettling. Humanity had sent machines to Mars, to Saturn, even to the edge of the heliosphere. But Eidolon was different. This probe was not chasing a planet or a moon. It was chasing a sound, a faint whisper in the cosmic dark, repeating every 10 days like a pulse from something patient and immense. Its destination was a set of coordinates derived from the faint resonance detected by the eventide array, a region of space dense with ancient debris, frozen bodies, rock fragments, and remnants of the early solar system that had never seen the sun up close. Somewhere among them, the third whisper called. Unlike previous missions, Eidolon was designed to operate without constant contact. It carried a self-learning AI system known as Sarah, modeled loosely on Lyra from the Asterian probe, but far more advanced. Sarah could navigate autonomously, adapt to changing conditions, and even prioritize discoveries without waiting for human approval. Its designers had built it to think in probabilities rather than commands, to explore in the same way humans dream, by making leaps of intuition within bounds of reason. And in its core storage, compressed among lines of code and data from Asterian, was every record humanity had ever gathered about 3I Atlas and 4I Prometheus. It was, in a sense, carrying our memory of the visitors back into their silence. For 9 months, Eidolon travelled through the outer dark. It passed fields of icy bodies that shone like dim glass, each one a relic older than civilization, With every million kilometers, the instruments grew quieter, the background radiation steadier, the space between signals longer. Beyond 50 astronomical units, even the sun was just another star. Yet in that great emptiness, the whisper persisted, a rhythmic pulse so regular it defied randomness. Every 10 days, the signal arrived, steady as a heartbeat. On November 7th, 2044, Eidolon reached the approximate origin point. Its sensors began scanning the area, mapping thermal fluctuations, magnetic distortions, and gravitational anomalies. The region was not empty. It contained dozens of small Kuiper Belt objects, most only a few kilometers wide. But one, designated KBO 2044 Panus, stood out immediately. It was almost perfectly spherical, a rarity among such small bodies, and it reflected light with unnatural precision. Unlike the dull, irregular textures of rock and ice, this one gleamed faintly even in the absence of sunlight. It was as if it had been polished by time, or by intention. Sarah focused all instruments on the anomaly. The object's diameter measured 4.6 kilometers, too large to be debris, too small to be a planetesimal. Its density, calculated from orbital perturbations, was unusually high, close to that of metal, and its rotational period was exactly 10 days. The match was perfect. This was the source of the signal. When Eidolon approached within 100,000 kilometers, its magnetometers began to tremble. The same low-frequency hum recorded years earlier from Atlas and Prometheus now enveloped the probe, faint but coherent. The waveform was identical, the same resonance curve, the same frequency range. The sensors logged it as type theta radiation, a classification invented on the spot. The closer the probe drew, the clearer the pattern became. Not noise, but a structure, modulating faintly over time. Then, at a distance of 20,000 kilometers, Eidolon's radar imaging finally revealed the object's surface. It was metallic, not rough or cratered, but smooth and etched with grooves so shallow and symmetrical that the onboard AI paused its own analysis, flagging them as non-geological. The grooves formed a lattice of spirals and intersecting arcs, patterns nearly identical to those seen on Prometheus, only magnified to planetary scale. In their intersections were circular nodes, each about 200 meters wide, arranged like the points of a vast constellation imprinted upon metal. Sarah transmitted the first batch of high-resolution images back to Earth. When the data reached mission control 18 hours later, it triggered the same reaction that had followed Atlas and Prometheus decades before: disbelief, awe, fear. The object wasn't just anomalous, it was designed. Too smooth, too symmetrical, too intentional. The patterns were consistent across hemispheres, aligned to the object's rotation axis, and, most astonishing of all, still faintly active. Spectroscopic analysis showed slow variations in emitted radiation across the grooves, as though energy were flowing beneath the surface, circulating through channels unseen. Within days, Eidolon descended closer, stabilizing in a slow orbit just 3,000 kilometers above the surface. Its instruments focused on the largest node, an enormous circular indentation nearly half a kilometer wide. As the probe passed overhead, Sarah detected a transient fluctuation in the local magnetic field, an oscillation perfectly synchronized with the 10-day signal cycle. The node wasn't just reflecting energy, it was generating it. And then, without warning, the signal changed. At exactly 0917 UTC on November 22, 2044, the third whisper broke its steady rhythm. For the first time since its discovery, it began to vary, shorter pulses, alternating tones, rapid sequences of modulation that no longer followed the 10-day pattern. It was as if something had noticed the probe's presence and was responding. The changes were not random, they contained symmetry, repetition, hierarchy. Within an hour, Eidolon's communication feed was flooded with data. The signal's amplitude rose sharply, overwhelming the sensors, forcing Sarah to enter a protective mode. The transmission, when decoded, was pure structure, binary waves arranged into clusters of 7, repeated across multiple harmonic frequencies. It was language-like, though not linguistic. It carried no voice, no message in any human sense, only rhythm and proportion. When researchers on Earth analyzed the raw data weeks later, they realized something extraordinary. The signal's intervals corresponded to atomic transition frequencies: hydrogen, helium, carbon, oxygen, iron. The building blocks of matter themselves. The message, if it could be called that, seemed to be stating the obvious. We are made of the same things as you. As the signal intensified, Eidolon's cameras captured one final image before its systems began to fail. The largest node on the object's surface brightened faintly, glowing from within. For 6 seconds, a line of light traced along the etched grooves, connecting node to node, forming a luminous network that covered half the sphere. The glow pulsed 3 times, slowly, deliberately, before fading back into darkness. Then the signal ceased. Total silence. On board, Sarah attempted to reboot its instruments, but telemetry showed rising internal radiation levels. The AI made a decision, its last act of reasoning. It reoriented the probe, directing its antenna toward Earth, and compressed all available data into a single encrypted burst. The transmission lasted 12 minutes before power systems failed. Then, Eidolon went dark. The final transmission reached Earth 2 days later. Contained within it was the image of the glowing lattice, the modulated signal data, and a final message from the AI's self-diagnostic log. Unknown external synchronization event detected. Correlation. Atlas Prometheus theta. Pattern complete. Pattern complete. Those words would echo across the world. Scientists and philosophers alike struggled to interpret them. Some said the 3 signals, the 2 interstellar visitors and the Kuiper belt sphere, formed a triangulation, a network meant to activate only when all were aligned. Others believed the alignment had already occurred, that Eidolon's presence had triggered a dormant system older than the sun itself. There was even a theory that the entire solar system had been chosen as a node in a galactic lattice, an ancient archive built not by a single civilization, but by countless ones over eons, each leaving behind a part of itself before vanishing. Months passed with no further signals. The sphere remained silent, inert once more. Some argued that it had simply responded reflexively, an automated process misinterpreted as communication. But a small group within the signal theorists saw something deeper. They overlaid the pulse patterns of Atlas, Prometheus, and the third whisper, aligning them by their frequencies rather than their dates. What emerged was a sequence, an ascending ratio that matched the harmonic progression of orbital resonance. Each object had emitted a part of a greater equation, one describing not distance, but connection. The mathematicians called it the chain hypothesis. If the hypothesis was correct, then 3I Atlas and 4I Prometheus were not travelers. They were keys, passing through different star systems, activating dormant archives scattered throughout the galaxy. Humanity had not discovered an alien civilization. It had stumbled upon their infrastructure. By 2046, the official narrative settled into cautious ambiguity. NASA and ESA declared the findings inconclusive, citing data corruption and the inability to verify the nature of the signal. Public attention waned once again, as it always did. But within research circles, the implications remained alive. A new branch of study, archaeometric cosmology, emerged, dedicated to deciphering cosmic-scale design principles. The idea that the universe itself could be a layered repository of messages began to take root. In 2048, as the last generation of scientists who had witnessed Atlas retired, a new kind of reverence began to surround the story. It became less a question of what the objects were, and more of what they had taught. They had not given us answers. They had given us perspective. In their silence, they had reminded us that understanding is not the same as knowledge, and that the universe may speak in ways that transcend comprehension. As for the Eidolon probe, it was never heard from again. Its orbit decayed slowly, carrying it toward the sphere it had discovered. Somewhere out there, beyond Neptune's pale orbit, it still drifts, frozen, intact, and silent. Perhaps, in that distant darkness, it now rests beside the object, part of the pattern it once sought to understand. And if the faint hum that still occasionally flickers through the eventide array is real, if it is not mere background noise, then maybe, just maybe, the conversation continues. Slow, patient, eternal. For those who still listen, the sky has never been silent since. The universe hums with memory, and the stars, once thought to be distant and cold, now seem to breathe. Somewhere, far beyond the reach of light, the architects of silence wait, not for answers, not for recognition, but for the next awakening. And when it comes, as it surely will, humanity will finally understand that it was never alone. It was simply late to the conversation. By the closing years of the 21st century, the story of 3-eye Atlas, 4-eye Prometheus, and the Eidolon probe had passed into legend. Yet it was a legend grounded in data, not myth. The images, waveforms, and recordings still existed, preserved in vast archives stored beneath mountains and in orbiting data vaults circling the moon. They were the sacred texts of a new age, the first verses of what future generations would call the listening era. Humanity had once searched for life among the stars. Now it searched for meaning. After the silence that followed the third whisper, the great powers of Earth shifted priorities. The wars that had simmered through the early century cooled, as if the species itself had grown suddenly self-aware. The scale of the cosmos made politics look small, even absurd. Nations began to cooperate in ways that had seemed impossible a generation before, united not by ideology, but by humility. For the first time in human history, the greatest race was not to conquer or to own, but to understand. By 2060, the listening civilization had fully emerged. Earth's night sky glittered with new constellations of listening satellites, arrays tuned not to capture data for profit, but to interpret the cosmic symphony of silence. Massive spaceborne observatories, suspended like metallic petals around Lagrange points, recorded not light, but the faint hum of interstellar memory. Humanity had finally accepted that communication might not come in language at all, but in pattern, in rhythm, in time itself. The story began with scientists, but it didn't end with them. Artists, theologians, and philosophers joined the effort, arguing that the universe was not an empty stage, but a composition, an ongoing arrangement of signals, each star and planet a note in an infinite score. The mathematicians described it in equations. The poets described it in reverence. They agreed on one thing. The act of listening was no longer passive, it was participation. The signal theorists, once fringe academics, had become cultural leaders. Their early idea that Atlas and Prometheus were not messengers but instruments had transformed into a philosophical cornerstone. Humanity had learned to see intelligence not as a binary state, but as a continuum woven through all structure. To them, even a star could be a form of mind, expressing itself through physics rather than thought. The universe wasn't merely alive, it was aware. Technology had evolved to match the revelation. Spacecraft were now built not to reach destinations, but to remain, long-duration sentinels designed to listen for centuries. Each bore a unique harmonic signature, so that if one day they were found by another species, they could be identified as part of the same choir. The Chorus fleet, launched in 2071, was humanity's greatest act of faith. 20 identical probes, each sent to a different edge of the solar system, programmed to listen, record, and transmit the faint patterns of cosmic resonance. They would drift for millennia, outliving empires, religions, and languages, machines built not to speak, but to remember. By the mid-2080s, The Earth had changed in ways no one from the 20th century could have imagined. Cities glowed faintly at night, powered by near-limitless clean energy derived from solar lattice reactors. Borders still existed, but they mattered less. Humanity had begun to think like a single organism, dispersed yet connected. The new generations grew up learning the story of the visitors not as science fiction, but as history, a reminder that understanding begins in silence. School children studied the Atlas Prometheus theta resonance pattern the way previous ages had studied alphabets. The numbers 0.314, 1.42, 10.0 had become symbolic, sacred in their precision. On the lunar surface, beneath the grey regolith of the Mare Tranquillitatis, stood the Observatory of Echoes, a monument to listening. It was here that the final transmission of Eidolon was displayed, repeating endlessly on a loop, the glowing lattice of the Kuiper Belt sphere pulsing 3 times before fading into black. Visitors came from across the world to watch it, standing in the low lunar gravity, their reflections merging with the projection like ghosts. It was said that those who watched long enough could feel something in the rhythm, a pulse that seemed to match the beating of their own hearts. Though the world had changed, one question remained unanswered. What were the architects of silence? The dominant theory by then was that the visitors were part of a galactic archive, a distributed memory system seeded by an ancient civilization long extinct. These objects, designed to survive the entropy of time, had been drifting from system to system, awakening when they encountered consciousness capable of observing them. Their purpose was not to teach or to warn, but to preserve the continuity of awareness itself. They were, in a sense, mirrors, cosmic instruments designed to reflect the moment when a species began to listen. But a smaller, quieter faction believed something else. To them, the visitors were not the remnants of intelligence, but precursors, natural structures in the universe's own evolution, born from physics, shaped by gravity and entropy until they achieved a kind of emergent sentience. The universe, they argued, was not hosting intelligence, it was becoming it. Every act of listening by any civilization was part of that transformation. Consciousness was not confined to biology. It was a property of the cosmos itself, unfolding slowly through time. In 2094, nearly half a century after the Eidolon mission, the Chorus fleet detected a faint harmonic modulation from beyond the heliopause. The signal was subtle, structured, and familiar. It bore the same resonant intervals that had once defined the Atlas Prometheus sequence. But there was something new in it, an echo of our own transmissions folded back into the pattern, as if the universe were answering not with words, but with repetition. The scientists called it the return wave. The public called it the reply. The event reignited the old wonder. For months, people gathered outside observatories and under open skies, watching the same stars that had once carried the visitors. Humanity was older now, calmer, wiser. It did not respond with fear or urgency, but with quiet gratitude. The reply was not a revelation. It was a continuation, a reminder that the act of listening is never one-sided. In the long rhythm of cosmic time, messages echo back not when we demand them, but when we are ready to understand. By the dawn of the 22nd century, the story of the visitors had transcended science altogether. It became the foundation of a universal philosophy, a faith without gods, a reverence without scripture. Humanity no longer prayed upward, but inward, seeking alignment with the rhythm that the universe had shown them. The listening civilization was not defined by conquest or technology, but by patience, the willingness to coexist with the unknown without needing to possess it. And so, the Earth endured, smaller than before in its ambitions, but greater in its perspective. The satellites continued to hum, the archives continued to grow, and the faint eternal pulse from beyond Neptune continued to beat. It had never stopped. Perhaps it never would. In one of the last transmissions sent from the Observatory of Echoes before its automation, a scientist named Dr. Helena Ward wrote a single line into the mission log, a closing reflection after decades of study. We have spent centuries asking if we are alone. The truth is simpler. We are surrounded by silence that listens back. And somewhere far beyond the edge of our light, two objects still drift. The first emissaries of that silence, ancient and patient, carrying the memory of their passage through a small system orbiting a yellow star. Perhaps, in another 1,000 years, they will awaken again, repeating their slow dialogue across the void. Or perhaps they will simply continue on forever, carrying within them the record of one young species that finally learned not to speak, but to hear. The universe no longer felt like a question. It felt like an answer we were only beginning to understand. The stars were no longer indifferent. They were waiting, and humanity, at last, was listening.